This is Casus, where you can edit the code for your tank and make it do different things depending on how you want it to fight. So Casus is a drag and drop programming language, and all of the code that you write here runs in your tank every frame. So there are 30 frames per second, and every frame of the game, all of your code will be run, and depending on what you tell your tank to do with the code, will change how it will act. So as just a quick starter, I'm going to go over how you can make your tank drive forward and shoot. So this, as I said, this runs every frame. So what we can do is we can just set what we want our tank to do right here, and then it will do this all the time. So one thing we can do is we can set shoot our primary weapon to true. So what this does is this will set some Boolean variable called shoot primary weapon. You can tell it's a Boolean variable because it's in these angle brackets kind of here. And then true is just the constant true. So this will set our primary weapon, or set whether we should shoot our primary weapon to true. We can also set our movement. So let's say we want to set our forward movement. And maybe we just want to go forward. So we'll set it to 1.0. We could go backwards and set it to negative 1.0. And maybe we want to set the direction we're facing. So maybe we'll set our target direction to, maybe we just set it to pi, which is 3.14159 roughly. So this means we will have our tank try and face to the left, which is like pi radians from straight to the right. We will walk forward at a speed of 1, and we'll shoot our primary weapon. So if we go to test code, this is the training arena, and then we can start our battle against the sitting duck bot, which will sit there. So here's an example of what that will look like. So this is our tank in the bottom left that we created, and you can see it's shooting its primary weapon, and it's moving to the left. That's exactly what we told it to do. So we can exit the battle early, and then we can go back to Casus to continue editing our code. So this isn't very exciting because our tank just does the same thing every frame. So maybe let's try and find something slightly more exciting or more interesting for our tank to do. We can keep track of what part of the lifetime of our tank we're at using a counter variable. So what we can do is we can set some counter variable, I'll call it C, to, we can increment it every frame. So let's set it to whatever it was in the last frame. That'll be C plus 1. So this will increment C every frame, so we can tell which frame of the game we are by whatever value C has. So now we can say that well, let's do an if-else statement. So maybe we care about whether C is less than a certain variable or bigger than a certain variable. So what I'm going to do here is, instead of going back into this variables tab, like if I want to get C, I can drag this here, and then I can click C, and I get it really easily. But if I don't want to do that, what I can do is I can right-click on the C variable, and I can get a copy of it really quickly. So that's a convenient little thing you can do. So if C is bigger than, maybe for 2 seconds we'll walk up. So 2 seconds would be 60 frames, or if it's smaller than 60 frames. Then we want to set our target direction to maybe 1.6 radians. So that's almost up. Or maybe let's just do 2. So it'll be like kind of up and to the left. And in all other cases, we want to set our target direction to, maybe it'll just be straight down. So that will be about negative 1.6 or so. So for the first 2 seconds, we'll walk kind of up and to the left, and then for the rest of the match, we'll walk straight down. And then you can see our tank will change movement then. All of these variables, like all integer variables and double variables, will initialize to 0, and all Boolean variables will initialize to false. So here we can see a quick little demo of the tank walking slightly up and then down for the rest of the match. Oh, so it's not moving, but it does turn. The reason it's not moving is because I never told it to move. So we can go back to Casus, and if we want it to move, we can just set the forward movement to be equal to, I guess we can make it move forward again, so 1. Now if we run it, then we can see this is us. We'll go up for about 2 seconds, and we'll turn and go straight down. And then we'll stop when we hit the end of the arena, because we're just hitting a wall. Okay, so that's pretty cool. That was just a quick demo of some of the blocks in Casus. Now I'm going to go through all of the blocks and kind of what they do, in case you're interested in those. So you can drag and drop blocks pretty easily. It's pretty intuitive where they can go. There's this little light blue bar for where you can place them, and it'll highlight where the block will go if you release it. If you release it somewhere where there isn't a light blue bar, it just deletes the block. So if I release it like over here, for example, then it deletes the block. You can also grab like a series of blocks if you left click, and you can grab just one block and everything it contains if you right click. So I can copy this entire if statement if I want. All right, so let's go through all these blocks. So here we have a for loop. That's very similar to for loops in other languages. Initially in the for loop, what you can do is you can, like, let's say we just want this, we can set c to some number, and then we can keep going as long as whatever is in here evaluates to true. So if we wanted to go 10 steps, then what we could do is we could say we want to continue, I guess right here, as long as c is less than 60. And then at the end, we want to increment c. So it might make a little bit more sense if in the beginning, instead of setting c to 0, or setting c to c plus 1, we set it to 1. So now this loop will run, whatever's in here, will run 60 times. So that's a for loop. We also have while loops, and while loops are very similar. You can do the same sort of thing as this for loop here, or not quite. There you go. So that's equivalent to the for loop that I had earlier. We can just make a copy of the for loop so you can see it. There you go. So that's an equivalent. This for loop and this while loop are pretty much the same as far as how they act. And again, the while loop just keeps doing everything inside as long as this is true. So it will check if this is true. If it is, it will run all of the commands inside of it. And then at the end, it will go back to the top, check if this is true, and keep running all the commands inside until eventually it comes to the top, checks if this is true and it's not true, and then it just continues after the while loop, just like a while loop in any normal programming language. If and else statements are pretty self-explanatory, so I won't really explain those. If else is just, if this thing is true, it does what's here, otherwise it does what's in there. Casus also has functions, so functions are pretty neat because you can define some function. So maybe this is like move forward. We can create that function. We can put it all the way up on the top. And then if we want to move forward, what will that be? Well, we probably want to set our forward movement to 1, and then we can maybe set our target direction to, I guess we can set it to 1 as well. So that will be just kind of like up and to the right a little bit. And then instead of doing all this stuff, what we can do if we just want to move forward is we can call this move forward function right here. And now if we run our code, we should move up and to the right. So you'll see that's exactly what we do. And we're calling this function every frame, so it's resetting that if we were to change it later. Another nice thing about functions is if for whatever reason your code gets really long and complicated, you can put some of it inside of like a helper function, and then you can just click this minus button and it'll minimize it. And that way you can like see less code, only see the things that you care about. And then if you want to go edit it, you can click the plus button and edit it later again, as you would expect. You can also do recursion. So you could call some method inside of itself. Here we'll get rid of these unnecessary if statements. can call this method. So what this method will do is it will set move forward to 1, set target direction to 1, and then recursively call itself. And then we will call this method once, and then again we'll have like kind of an infinite loop, but really it's infinite recursion because it's going down the call stack. So if we do this, we'll have infinite recursion, and that's a problem. And obviously we don't want to crash the browser. So I'll show you how Casus handles that. You'll see this health bar on the top, and that shows your name and your health. And then it also shows what items you have. So you can see the sitting duck has 2 different items, and they're indicated here. And as they use them, they'll disappear from this health bar. But here we get this warning, and the warning says that the recursion is too deep. So after you go about 1,000 layers deep into the recursion, in order to make sure your browser doesn't crash, we automatically cut that off, and we'll give you this warning here too. Another way you could crash the browser is if you had an infinite loop. So I'll show you a quick demo of that here. That's really simple to make. We can just do while true. It will run this loop forever. So if we test this code, then our tank isn't actually doing anything because we didn't tell it to move or turn anywhere or whatever. But it's just going to run this infinite loop. And you can see it says there are too many instructions because it cuts our tank off. It tries to do as many instructions as it can. It does. It always does the same number of instructions, and it does roughly 50,000 of them. Like it executes 50,000 blocks. But it's deterministic, so it will always do the same thing for everyone else on any computer. You'll notice the game slows down a little bit, and that's because it's trying to help you do all your instructions. And I'm running this on a fairly slow laptop, so that's part of the reason why. If you notice it's running a little bit slower, it might be because one of your tanks is very demanding as far as the Casus code that it's running. Okay, so those are all of the control flow statements. These are kind of very useful. To go into some more very useful statements that we've already kind of looked at are the variables. There are 3 different types of variables in Fortuna. There are int variables, Boolean variables, and double variables. So an int is just some integer, 0, 1, 2, 3, 4, -5, something like that. They go up to 2 to the 31, and all of the it'll overflow if you go beyond 2 to the 31. So you can use int variables for things like counters. You can use int variables with lists, as we'll talk about later. And you can also use int variables for things like you can check. Well, I mean, there are several things you can do with int variables, but they're fairly useful. Boolean variables are just true or false values. So one thing that Boolean variables are very useful for is like whether you want to use your power-ups. Those are all Boolean variables. So if you equip Nitro Repair to your tank, you can use Nitro Repair by setting use Nitro Repair to true. And then the first frame that your Casus code says to use Nitro Repair is when you'll first use that. There are a bunch of other power-ups you can use as well instead of Nitro Repair. You can use your jammer, and if you just keep your jammer used as true, then your jammer will get used as often as you can. But that might not be the best idea because you might use it and then the opponent will come into your range and then it's still on cooldown, so you can't use it until it finishes cooling down. So there might be better ways of using your jammer than just setting it to be true. Similarly, for your primary and secondary weapon, you can decide whether or not you want to shoot them. And obviously, if you want to do damage to your opponent, that's a very good way of doing damage. But you don't want to be shooting when you don't need to be. And to emphasize that, you'll notice that when you shoot your primary weapon or when you shoot your secondary weapon, your speed is a little bit slower. So if you don't need to be shooting, you probably shouldn't shoot. And you should wait to shoot until you are confident that you can hit your opponent, because otherwise it'll make you move a lot slower and be a lot easier to hit if your opponent's trying to shoot you. You can also choose whether or not you want to use mines in C4. So to use a mine, you can set this variable to true, and then if you set it to false and you have a second mine, for example, because you can have multiple mines, if you set it to true, you'll place the mine. If you set it to false, you can set it to true again later to place your second mine if you have a second mine equipped. Similarly, to use C4, if you set it to true, you'll place the C4. If you set it to false, you'll blow up the C4. That hurts your tank and your teammate tanks and enemy tanks. Mines will automatically blow up when someone comes near them. We've already talked about your jammer and nitro repair. Overdrive is similar to nitro repair. It's like a one-time power-up use, and then you set it to true when you want to first use it. And then your missile tracker is a missile tracking dart that you can use as well. Okay, so those are all of the Boolean variables. There aren't any built-in integer variables, but you can make them. You can like make some variable x, for example, and now we've made our own variable x. And you can do the same thing with Boolean or double variables as well. For double variables, there are a couple of built-in ones. There is your forward movement, so this can be some double between -1 and 1. If you set it to something bigger than 1 or smaller than -1, it will just be 1 or -1 respectively. Your target direction is what direction you try and face. So all that matters is the value of this mod 2pi or mod tau, and that is the direction your tank tries to face. You also have this variable for your turret direction. So this is the direction your primary weapon faces. Your secondary weapon's mounted to your chassis, so it's always going to face whatever direction your chassis is facing. But the turret direction of your primary weapon is something you can aim, so you can aim to your side, aim to the side while you move and try and dodge bullets of the opponent, for example. The tank X and tank Y are the X and Y coordinates of your tank. 0, 0 is the middle of the screen, and then different maps are slightly different sizes, but they go up to roughly like 150 plus or minus X, and then like 70 plus or minus Y for the smaller maps. Okay, yeah, so those are the variables section. We also have the math section. This is very self-explanatory. You can take the cosine of some number in radians, takes in a double, outputs a double, as you can see by the shape of the block. You also have sine, tangent. Arc cosine is the inverse cosine, inverse sine, inverse tangent. Take the square root of some number, and you can take some number to some power. All of those should make lots of sense if you've done math. One thing you can use arctan for is finding what angle you should face if you want to go towards a certain point, for instance, and I'll do a demo of that later. So for the int blocks, we have equals, greater than or equal to, less than or equal to. So those are for comparing two integers, for instance. You can also do integer arithmetic, so you can add, subtract, multiply, divide, and take the remainder after division. It's modulo. This is integer division, so it drops the whatever the remainder is. So if you do like 3 divided by 2, you'll get 1, because 3 divided by 2 is 1.5, but it will drop the 0.5, so you'll just get exactly 1, the integer 1. 3 mod 2 would also be 1, because 3 divided by 2 is 1 remainder 1. If you don't want to do that and you want your division to give you 1.5, you can convert your integer to a double with this toDouble method, and you'll notice it's got this squared off corner on the bottom, but a rounded corner on the top. And that's the shape that all double blocks have in Casus. So if you do this, then you'll get a double method, or you'll get a double returned. You take the absolute value of an integer, take the max of 2 integers, and the min of 2 integers, and all those are built in for you. Doubles are very similar. You can check if 2 doubles are equal, greater than, less than or equal to, greater than or equal to. And then you can also do your double arithmetic. You can also round a double to the nearest double, and you can truncate a double by like cutting off the part after the decimal point, and that will return your integer. Rounding also returns an integer. You can also take the absolute value, max and min for doubles as well. Logic is Boolean logic, very straightforward. So and, if both of these things are true, it will return true, otherwise it'll return false. Or will return true if either of the two things you pass in these blocks are true. XOR will return true if these two things are different, and not will return true only if the thing in the middle is false. So that all should be fairly straightforward. XOR is a little confusing if you haven't used it before. One thing I should mention is that if you don't fill something in for these blocks, it will treat it as false. And similarly, if you don't fill something in for one of these, it's as if you pass in 0, which is the default value for doubles. Any Casus code that you can put here is legal. It will run. If you do something illegal, it will kind of skip the command. So if you try and take the... Hi, Siri. You can run any code that you'd like. Casus won't crash. It just will ignore commands that are illegal. Okay, so lists are also quite helpful. Lists are similar to arrays in other programming languages. You can do different things with them. So one thing you can do is you can append a Boolean value to a Boolean list. And you can tell that Boolean lists have the Boolean shape on the left, and they have this jagged shape on the right, and the jagged shape indicates it's a list. So you have the same thing for int lists and double lists, the int shape on the left and list shape on the right, for instance. So you can set some index of some list to some value. So if we've got some integer list. Maybe this is our int list. So we can set that our int list. Now we need some constant. Maybe we want to set the first thing at it. Maybe we want to set that to -5. So that will set the thing at index 0 to -5, assuming there is something at index 0. If we just want to add -5 to the end of the list, we can add -5 to our list, and that's what it will do. So that's append. We can get some element of some list, and that's pretty straightforward. So we get some list at some index. The index is always an integer. If you try and get an index that doesn't exist, it will return 0 if it's an int or a double, or false if it's a Boolean. You can also get the size of some list, and that's here, which does pretty much what you'd expect. Tells you how many things are in the list. Finally, we have debug statements. So these are nice if you are kind of confused as to what your code is doing, or you need to see some value. And there's a built-in like debug logger in Casus, so you can see how things work. So let's say, for example, we want to set like we want to make some counter, maybe we call it C, and every turn we increment C like we were doing earlier. Then what we could do is we can print the value of C. So every frame, we'll see exactly how many frames have occurred. So if we test our code, you'll see that as soon as the battle starts, we print out all of these numbers, and you'll see which tank printed it, as well as the value that it printed. So this is our starter tank, and it's printing just whatever C is. So now we've seen that there are about 450 frames that have happened so far. And that's how you print out variables. You can also print out Boolean or double variables if you want to get information about where things are. So let's continue with different things you can do. The last thing I want to do as far as these blocks go is go over what lists we give you. So here are a couple of the lists. This isn't necessarily all of them. So maybe we want to, okay, well, here we go. So, we want a double list. Let's just print it. So here, what we can do is we can look at all of the lists that we have, and we're going to get this list and print it at some index. So the enemy tank X's and enemy tank Y's are the X's and Y's of tanks that are on the opposing team. This will only show tanks that are in your scanner's range. So if that tank is out of your scanner's range, you won't be able to see it, and it won't appear in this list. The friendly tank X's and friendly tank Y's will be all of your team's tanks X's and Y's, and you can use those to make sure you don't shoot your teammates, for instance. Explosive X's and explosive Y's, if you have a scanner that has like an item scanner attachment enabled, then you'll see all of the mines and C4s that your scanner can see. You You can also see all of the wall X's and wall Y's so that you don't walk into walls. And that's very helpful as far as navigation. So that way you can find the shortest path to your enemy, or you can find a good way to hide behind the wall so you don't get shot by your enemy, or you can do all sorts of interesting things with that. And that will show you all of the walls in the map, and you can use that to avoid them or navigate around them and stuff like that. All right, so now I think one last thing that might be helpful is I'm going to go through how you could make your tank walk toward the opponent and then shoot at it. So I'm not going to cover navigation here because that's kind of an interesting challenge left to the user. But you'll notice in this test example, we start to the bottom left. In this case, we're going to spawn to the bottom left, and we want to navigate to the top right. So what I'm going to do is I'm just going to walk up and to the left for a little bit, and then I'm going to walk straight right for a little bit. And then that'll get me somewhere near this tank where I can see him. You can see this is my scanner radius right here, so I have to get within that distance of him in order to be able to see him. So I'm just going to kind of hard code some navigation in order to get near him, and then I can show how you can aim at him and shoot him. So it will be pretty helpful to have a counter. This will show what frame we're at, or tell us what frame we're at, and that should be helpful for the hard-coded making decisions. So if C is less than 100, maybe for the first 100 frames, then we will set our target direction to, I guess we want to go up and to the right a little bit, right? So maybe we'll do stuff in terms of pi, so it's easier to think about. So maybe we want to go pi times 0.5 would be vertical, so maybe we want to go pi times like 0.55. It's a little bit to the left. And then after the first 100 steps, we just want to go straight to the right. So we'll set our direction to 0. We also want to make sure we move, so we can just always go full blast forward, which isn't very exciting, but I guess it works, right? So we'll go straight up and then straight to the right, and we can test our code here to make sure we do what we want. So there you go, we're going up and to the right. And wasn't quite far enough, so maybe we'll do a few more frames of that. So maybe instead of 100, we'll do like 110. Maybe 115. So let's see how that works. So in general, just like hard coding directions isn't very useful because your opponent's probably going to be moving too. This is just kind of a lame example. But yeah, that works. So this would be helpful. The issue is we're not really shooting anything, so we're not going to hit our opponent too often. So instead of doing that, what we can do is we're going to have to start shooting after a certain amount of time. So maybe we can set whether or not we should shoot. We don't have a secondary weapon at the moment, so just use primary weapon. We want to see if C is bigger than some number. So if C is bigger than, it's kind of just a guessing game at this point because there's not much logic going on here, but maybe C is bigger than 200, then we'll start shooting. So now we can watch what what happens there, and you'll see he goes up to the right and then eventually starts shooting, but probably won't hit the opponent because he's not aiming at him. He's just always aiming to the right. All right, so yeah, as you can see, not very helpful. We're not doing any damage to the opponent here, so that's not great, although it's kind of working. One thing you'll notice is that I'm kind of hitting the wall. So instead of setting my target direction to 0, I'm going to set it to something that's just slightly negative. So maybe like negative 0.001. So that should kind of help not clipping the wall as much. So the last thing we are going to want to do here is we're going to want to aim at the opponent. So what we can do is we can set the turret direction. Well, let's calculate the difference in x and difference in y between us and our opponent. So let's make a variable called difference in x, or like dx. That works. And then we want to set that to whatever the opponent's x is minus our x. And then we're also going to want to have the difference in y. Or no, tank y, rather. Okay, so now we want to get whatever the opponent's x is. So we can look at the opponent's x list. And then we can also look at the opponent's y list. So that's the enemy tank x's. Similarly, the enemy tank y's. So this will get us whatever list we care about. And then we want to access index 0. All right, cool. So we can set this dx and dy variables to some value, and then we'll have these variables set, but we haven't actually done anything with them. So then what we can do is we can like set some variable called like target angle, or I guess we can just use our turret direction. So we'll set our turret direction to, we want to set it to the arctan of y over x. And if you work out some trigonometry on paper, you'll see this will do what we want it to. There's one issue though, which is arctangent returns something between negative pi and pi, but it's possible, or negative pi over 2 and pi over 2, but it's possible that the other tank is to the left of us. And if the tank is to the left of us, this will only give us the angle that's like to the right. So we'll be off by half of the circle. So we need to handle that, and a good way of handling that is checking if our dx is less than 0. And if it is, then we need to handle the target direction better. So if that's the case, we want to set target direction to whatever it used to be. Plus pi, because that will offset it by 180 degrees, or pi radians. So this should make us point at the enemy if we can see them. If we can't see them, then this will return 0 instead of whatever the enemy tank x's actually is. So that's a bit concerning. Or I don't know, it's not concerning really. We'll just point at the origin, the middle of the screen, instead of at wherever the enemy is facing. So that would work fine, just to make it a little more interesting, I think. What I'm going to do is I'm going to change this to say, we're only going to do all of this stuff if we can actually see the enemy. Otherwise, it doesn't really make sense. We're just kind of like looking at random random things. So we only want to do this if the size of the enemy's list is bigger than 0. So we want the size of the enemy tank X's for instance. That would be just fine. If that's bigger than 0, then we want to look at the enemy tank. All right, so this is all of the code. I just wrote it for the first time here, and hopefully this winds up working as we expect. So what we're trying to do is we're trying to walk up and to the left. After we do that, we're going to walk to the right, and then we're going to, right here we're not aiming anywhere because we don't see him, but once he gets into our radius, you'll see we point our turret at him and we start shooting at him. And eventually we start doing damage to him. You'll see his health goes down. Oh, that's a problem. So looks like we're handling the X being too negative incorrectly. So let's go fix that. So we're setting the turret direction to the target direction plus pi. We should be setting it to the turret direction plus pi. So that's an easy fix. Now we're setting it to the turret direction plus pi. And now if we run it, then we should see more of what we expect. So you'll see we snap toward him. And then we're going to start shooting him, hopefully. There we go. And now we're handling these angles correctly. So we're using the grenade launcher here, which is why we get all these nice particles, but there are lots of other weapons we could use as well. And there we go. We ended up killing him. So that's kind of what the goal is. And that's a general overview of how you can use Casus code. So I hope you enjoy creating interesting tank logic and figuring out how to do navigation and stuff like that. Thanks for watching.